In this video, I want to talk about the welders that we have at our disposal here in the shop. We actually have 4 options for welding. We have the spot welder, which is the simplest. We have the torch. I showed you how to cut and bend metal with the torch in one video. This time I'll show you a little bit on how to weld and braze metal together with it. We also have our arc welder right here, which is probably the most difficult to manage. And lastly, we have our Mig Welder, which is an auto feed welder, and it might be the easiest. So I'm going to go through the basic operations of all 4 of these types of welding real quick. Again, most of the information that you would need is up on the wall and on the machine. So if you just do a little looking and reading, you can figure out what's going on with the welder. But I will talk to you about some best practices and some things that can go wrong when you're trying to weld. This is our arc welder. The reason that it's called an arc welder or stick welder is because it functions by creating a short circuit, basically. So an arc, right? The electricity arcs out. So when you first encounter this welder, you're going to notice 2 big cables that come out of the bottom of the welder, and usually they're wrapped around this handle. One of them is the ground line, right? It's a clamp. You need this ground line to be as close to your working piece as possible. If you're welding something large, clip it right to the working piece. And ideally, you should have it fairly close to where you're going to be welding. I don't mean within inches, but maybe within a foot would be good. Now, if the piece of metal that you're welding is very rusty, you may have to grind a little spot where the clamp touches so that we can get we want a good contact. It's electricity that we're dealing with here, so we want a good contact. We want the electricity to be flowing through the steel. It doesn't mean that you need to grind the entire piece. That electricity, that electrical current will flow through inside the steel. But sometimes you need to grind a little spot where the ground clamp goes. Now the other cable that comes out is this, and this is the welding head. So in this handle you put the electrode, and this is a combination of a fill rod and a coating that helps to ignite your spark and get the metal to melt better. It gives you a better weld. Okay, you clamp that in there, so you squeeze that to open it, and you put your electrode in there. The on-off switch for this welder is right here. It's clearly marked as power. When you turn it on, you'll hear the welder come to life and you'll hear the fan start up. I recommend you do not turn this on until you're all set up and ready to go. If it doesn't do anything when you flip this on, make sure the machine is plugged in. The plasma cutter also uses these bigger 220 plugs, and sometimes these machines get unplugged. Best to check that out first. When you weld with this, the idea is to get your workpieces secured, either using magnets or clamps, whatever you need, because you're going to have to tap this electrode to get it started. You'll see what I mean in a second. Now to set this up, this is very complicated because you can weld all different kinds of things with this machine. You can weld aluminum, you can do a lot of different things that you probably will never do unless you really get into welding. But for the purposes of what we're using this for, you can set it up according to the sheet that's in the clear plastic thing on the top of the welder here. So that means the electrode needs to be set to negative. The amperage adjustment is here, and you adjust that based on the thickness of the stick that you're using and the thickness of the material that you're trying to weld. I find that I sometimes have to tinker with it a little. If you're using very thin metal and you try to weld and it burns right through it, then you know it's set up too high. On the other hand, if you're using something that's fairly thick and it just doesn't seem to be sparking, or it's splattering a lot and you're not getting a good weld, then you need to crank it up a little bit. So, as with so many things in the shop, have some scrap pieces that you can practice on. I'll show you how this works and what it looks like. So I am going to try and do a butt joint where I just weld these 2 pieces of metal together, right like that. They've already been grinded a little bit on the edges, so I have a nice spot of bare metal where I can weld. And that little gap is can be actually useful because it'll let some of the weld get in there and can make it a little bit stronger. If those weren't beveled on the edges, I might take them to the bench grinder and bevel them off real quick, just so that I had a little groove to put my weld in. Now this is going to move around, so what I would do to keep this steady is use one of these magnets, just to give myself a little security. So now the magnet is holding that in place. I'm going to try to just do a weld right here. So first I have to attach my ground line. Now since the table is metal, I don't have to clamp it right to my workpiece, so I can just clamp it right here, and that should be close enough. I'm going to put my gloves on, I'm going to turn on the vent fans, and I'm going to grab my welding helmet, and then we'll see if we can get this to work. Turning up my amperage a little bit because I didn't like that weld. It didn't seem strong enough. Let's see if this is better. Much better. I missed the joint though. When you weld something and you're all done, under the weld is actually under this stuff that's kind of like glass, and you have to crack that off to see how you did. So you use what's called a slag hammer, and you just smack at it. Now this will throw chips, so you want to have goggles on, or you can just put your welding shield down for a minute. I didn't do a very good job. I only got one spot that really welded. That would probably break. So I'm going to try it again. Now, something that's maybe counterintuitive, I'm going to try it from the other side here. Since it's welded a little, it won't move around on me as much. I'll still use the magnet. Now, something about welding, when you're working, and notice these electrodes get smaller and smaller. At some point I'll have to go get another one. When you're welding, it's a good idea to push like this and not drag. I think that was one of the mistakes I made. You'll also notice that when I start welding, I have to tap it to get it going, right? That's to try and get the spark going. The trick with an arc welder is you want to tap it to get the flame going, but if you pull it too far away, it goes out again. So you have to tap it but keep it close. If you tap it and hold it on there, then the electricity continues to flow and you'll just weld your electrode to the workpiece. When that happens, you know it, and you end up having to release this and the rod is just stuck to the workpiece, and that's not good. So if that does start to happen, make sure that you pull the electrode, pull the handle off the electrode, turn off the welder, and start again. Let me see if I can get a better weld on this one. Time to get another electrode. One of the tricks to welding is, once you put your mask down and it starts to weld, you can't see very well. So it's hard to see what you're doing. So you have to kind of know where you're working. Okay, I've turned the fans off. Let's see how we did here. Get that out of the way. Again, I'm going to use my slag hammer to break the coating off. It's still very hot. I'm also going to use a wire brush, and then I can really see what I've got. So, let me grab a pair of channel locks here so I can pick this up and show you. So, not terrible, not great. I've got some pitting here, but this is starting to look good. If you see that pattern right there, you're starting to get a good weld. It looks like, welders call it a stack of dimes. So it looks like a bunch of dimes laid on top of each other, sort of overlapping. This was just sloppy. I didn't know where I was going, but the settings are right. The settings are right on this. Now I could take this and use an angle grinder and flatten all that out and have not a bad weld. These pits would probably show up, so I might end up wanting to fill them. But that's a pretty good weld, and that's stuck. That's stuck together. A lot better than that side. So we're getting somewhere. Like I said, arc welding is probably the most difficult of the three kind of welders. Having the right protective equipment on when you're welding is very, very important. I have a long sleeve smock and my leather apron on. I also have the welding gloves, which are insulated. These are different from regular old work gloves. You've seen my work gloves that I use in the shop. These are different. These are metalworking gloves. They're thicker, they have some insulation to them. Also, when I'm welding, I need to use a welder's helmet. Now, this is different from the kind of face shield that you would use if you're using the oxyacetylene torch. The oxyacetylene torch won't burn your eyes quite the same. So this is just like a really dark pair of sunglasses for the oxyacetylene torch. But this will not cut it for the welder. If you try to use these with the welder, you will burn your retinas. And that can last for days, weeks, months, depending on how bad you do it. So you always have to use the right face shield. Now, you know if you're using the wrong thing. The minute you start welding, it's like you're looking at the sun. So you want to make sure that you have one of these, and you want to make sure that it works. Some of these have an auto darkening system, which is really great because when you put it on, you can see through it. And then the minute that the flash starts to amp up when you're welding and it gets super bright, it darkens itself. But to know if that works or not, inside the helmet, there's a button that says on. And all you have to do is push it. And when you push it, it should light up green. Let's see if I can show you that. There. So you get that little green LED, and that tells you that the batteries are working and it's on. If you push that and the little red LED lights up and it says low battery, don't use it. Bring it to me and I'll change the battery out. Not all of our welding masks have that. This one is just a plain old welding mask. It does not auto darken. It also means that if you put it on and you put it down, you can't see a thing through it. So traditional welders get all set up, they have their piece in place, they have their rod right where they want it, and then they go and start welding. But if you're just starting out, probably not a good one. I would use the auto darkening one. Also probably goes without saying, but I'm going to say it anyway, make sure you're wearing long pants when you weld. I made the mistake one time of welding in jean shorts, and it was like the worst sunburn I ever had on my legs. Don't do it. My legs turned purple. It was awful. So make sure that you wear long pants, long sleeves, gloves, welding helmet. This is our Millermatic Mig Welder. MIG, or M-I-G, stands for metal inert gas. Whereas the arc welder has the electrode with the coating on the outside, instead of having that electrode and coating, this welder uses a bottle of inert gas, argon, and a spool of metal on the inside of the machine. You can see right there. This is called an auto feed welder. Similarly, you have two big hoses that come out of the front, or wires. One of them is the ground line, just like the arc welder, and the other one is the nozzle. This nozzle has a trigger, and when the welder is on, it auto feeds wire out, and that's your fill rod. Now, you would never want to start with it that long. I'll show you how to trim this up and get started. And I think I have to clean this tip up a little bit too. If you're interested in welding, I recommend starting with the Mig Welder. It is the simplest. It even has less adjustments. The on-off switch is clearly labeled down here, and you know it's on when the light comes on. You have this material thickness dial, And this just adjusts the voltage. And it even tells you how to set it. So I'm going to be trying to weld some steel that's about 3/16 of an inch thick. So I'm going to set it up a little higher to that. And then you have your wire speed. And this is how fast the wire comes out the end of the nozzle. I recommend you leave the wire speed on auto. But if you're trying to use this and it's not working quite the way you want it to, you can fiddle with that. If it's going too fast, what it's going to do is it's going to splatter. If it's going too slow, it's also going to splatter inside the nozzle. You'll know when you have a good weld, and I'll try to demonstrate. Also, when using the MIG welder, you need to turn on the argon, the gas, the inert gas, and you need to set the regulator. And again, if you forget, the information for this is up on the wall. If you have not watched the video yet for the oxyacetylene torch, please watch that. But again, the way these work, you start by opening the valve. You'll see the needle twitch a little bit. This tells you how much gas is left in the tank. This tells you your pressure coming out the regulator, and this is the regulator. So right now it's loose. There's no pressure going in the line. I need to set this to about 25 to 35 CFH, which is the black on here. So that means I'm going to set it to between the 10 and the 15 mark on the LPM, which is the red. And all of this is on the dial. You can see it right there. So I want this right about between 10 and 15. That should be good for me to weld. So this time, I'm going to weld a right angle. This has been grinded a little bit, so it has a little beveled edge which will accept the weld nicely. Some clean steel here. I'm going to use my magnet to stand this up on here. And then I'm going to weld right in that spot right there. Now I've got my ground clamp, and I'm going to put that right here by the workpiece so that I know I have close contact. And before I turn on the welder, I want to get this ready. So the first thing I'm going to do is snip this. I want this piece of wire to be sticking out between 1/4 and 1/2 inch. And I have these special pliers that are made just for the MIG welder. These live in the toolbox over there. You can use these, but make sure that you don't just let them sitting here when you're welding, because the slag will burn up the grips. So you can snip this wire and then set them on top of the welder or somewhere out of the way. So that's a good starting spot for my MIG welder. There's a trigger on this, and when I want to start welding, I pull that trigger and I'll be good to go. We'll see how this goes. So I'm going to put on my gloves and my welding helmet. I have to turn on the vent fans, and we're going to be ready to weld. Now, the same as with the arc welder, I want to push. I want to push my weld, not pull towards me. Sometimes that's a little counterintuitive, and I'm going to just slowly go back and forth to try and stick the two pieces together. As you can see, the MIG welder is so much easier than the arc welder. So now, I'm going to do the same thing. I'm going to use my slag hammer to see what my weld actually looks like. Actually, there's not even any coating on that like there is with the stick welder. That is just steel right in there. So that is stuck together. Now that's a pretty thick weld, but I could get in there with the angle grinder and clean it up a little bit. If I was doing finer work, I may have dialed down the... Actually, I might have wanted a little bit higher amperage because it might have dug in a little. Let's see what that looks like if I turn the amperage up a bit. Let's try it on this side and see what that looks like. Again, that's a little too long for me to start. Not bad, but I'm going to cut it back a tiny bit. So about there. I think that might be a nicer weld. It's a little bit smaller. It looks pretty tight. See how that one's a little bit globbier. Not quite so neat. This one looks pretty good. Now what I did to adjust that is I changed amperage by turning it up a little bit, because this metal is, it's probably 3/16, but I set it up closer to 1/4. I also I changed the wire speed from auto to 60, which is about right in the middle of the dial, and that just seemed to go better. So sometimes this is trial and error, and again, I recommend you work with scrap pieces and test things out. One last very important note about using the MIG welder. If you ever turn the MIG welder on and you pull the trigger and that wire does not feed out, stop immediately and come and talk to me. Something that can happen sometimes when you're using the MIG welder, if this tip gets dirty, and right now, I don't know if you can see that, but it's pretty grubby. So I need to clean this tip out and replace it. It still works, but it's getting pretty gross. At some point, especially if you're new to welding, when things are splattering and it's not quite working right, you can sometimes weld the tip of that fill rod to the electrode tip that it's coming through. If that happens, the machine is still trying to feed you metal. But if it's not coming out here, what happens is it winds up inside the machine and it creates what they call a bird nest, and it looks like a bird nest. It's very difficult to get out of there. You have to kind of take the machine apart, pull everything out. It's not the end of the world, but it does waste a lot of material, and it is a pain. So please, if the welder's on and everything seems to be working and you pull that trigger and this little rod does not come out, stop and come talk to me and we'll figure out what the problem is. When you're done using the arc welder or the MIG welder, you should wind up the set of cables on the front of the welder the way you found it when you started. If you're using the MIG welder, when you're all finished, you need to shut off the gas and bleed the line. And again, if you haven't watched the oxyacetylene video, you should watch that video. But all I have to do is turn the valve towards close, and then I'm going to bleed the regulator out. So I'm going to loosen this regulator knob until it rattles a little bit so that I know it's completely closed. And that's a little counterintuitive. As you loosen it, it closes. As you twist it in tight, it opens the valve. And then the last thing I'm going to do is bleed the line. And to do that, what that means to bleed the line is to bleed all the gas out of the line or hose that's coming to the nozzle. To do that, I have to turn the welder back on for a second. So the light is on, I can hear it, I know that it's on. What I'm going to do is push the trigger real quick and watch the needle on the valve drop. That's it. It doesn't take very long, but it does shoot out a little bit of extra wire. So if you ever wonder when you start to use the MIG welder why sometimes there's this extra bit of wire sticking out, that's why. It's because somebody bled the line and they just shot out a 5 or 6 inch section of wire. No big deal, snip it off, you're ready to go. Welding is a very different process from woodworking, but the thing they have in common is doing both, you can make a big mess. You get very dirty from the carbon that comes off of the welding. Also, there is usually a jumble of tools. Since you're working with fire and you're working with something that's a bit time sensitive, you're kind of throwing tools around, and it makes a big clutter. When you are all done working down here in the welding booth, set it back to 0. And by that I mean put everything away. Put the vice grips back on the magnetic tool holder, put the MIG pliers back in the drawer, clip your gloves together and put them back in the drawer where they go. Make sure all of the hoses are wound up. Make sure everything is put away, and even your scrap steel. If it's big enough for someone else to use or practice on, put it in the scrap steel bucket underneath the brake and roller slip roll machine. If it's too small for anyone to use, you can throw it in the trash can that has all of it's the metal silver trash can down here, and it already has a lot of metal in it. We're going to use that for recycling.